Hello everybody, I will start my day with another coding practice. So in this video, I will solve a question jump game. So in this question, I'm giving an integer array nums. I'm initially positioning the array's first index, and each element in the array represents the maximum jump length at that point. Return true if you can reach the last index, or false otherwise. I see. So in this question, I'm giving an array of integers, and which represents the kind of yeah you know how should I say yeah a kind of places. I can think that one element represents one place, or I should say one slot, and the integer in that slot represent how much distance I can jump from there. And my task is if I can reach the last index from start. Yeah, first index. Okay. So let me think with some example. So say I think the most simple case is like this. In this case, yep. Also again, sorry. I just want to confirm makes makes the confirmation on the input. So each element in the nums array is 0 or more. So in the case of 0, I cannot move from the cell. So obviously I shouldn't reach that, jump to that cell as long as, unless it is the final last position. Also, there is another constraint which says length of the nums is 1 or more. So yeah, in the case of 1, obviously when I start the game, I'm also at the last position, so I can just return true. Okay, so let me think. So firstly, with this example, obviously I can jump to the next cell, next cell, next cell. So this should be true. And there should be definitely 0, cell in the case I cannot reach the last index. Yeah, for example, in this case, if I start from here, I jump to this. Oh, wait. Maximum jump length. Okay, so I don't have to go here, but I can go here. So let me, for example, this. In this case, I start from here, and then even though I can jump 2 steps, I jump only 1 step. Then from the second cell, I jump the 2 steps. Yeah, and then I can reach the final, last index. Yep, so that's how it works. Okay, so I will return Boolean if I can reach the last index or not. Okay, so let me think of the algorithm. So yeah, I think I can use the dynamic programming for this approach. So firstly, I'm at this position. Now I can say I can reach here. And because I can jump 2 steps, this and this are also possible. Yep. I can reach them. And then the cells after the first element, out of these 3 steps, I will take a look at the first cell I can reach. So it should be here, and everything from here where I can reach, because I can jump 2 steps. This cell and also this cell is reachable. Then at this moment, I find that I can reach the last index, I can just return true. Okay. Let me think of the case when I cannot reach the last index. In this case, from here, I start from the index 0, so this is also always true. And yeah, because I can jump up to 2 steps, this and this, these 2 cells are possible to be visited. And so after this, I will start from this cell. So I can jump from the next cell to 3 steps later. Yep. Then I will start from this cell 0, but obviously this is 0, so I can't jump. And same for this, I can jump. Same for this, I can jump. So in the end, I couldn't reach the last index. Yeah, because there isn't any cell later than this, which is true. Yeah. So yeah, it's impossible. So that being said, yep, I will take a look at each cell, and if it is visitable, I will try to jump to the next cell, every possible next cells, and update the next cells with true. I mean, reachable cells with true. So I mean, I will just keep track of the reachables, which is a Boolean array. Then, yeah. For each index, I will take a look, and if it is true, I will update the reachable cells with true. Okay, so that's what I will do. So obviously, this is the bottom-up DP, because from the subprogram, I mean, if I think of this cell, from every possible cell which can reach here, I will, okay, so this, what I'm doing is the opposite of something I will tell you from now. So if I try to reach this cell, I will take a look at past cells which can reach here. And if there is a cell which is reachable and jumpable to here, this is true. So I will do the opposite of this in this solution. Okay, so let me start the implementation. Yep, so this is the cell where I should initialize, and what I should do is for each cell, I will try to check so this is the max distance from the start cell to which I can jump. Yep. Okay. So in this way, because this cell is now reachable, I will update reachable this position with true. Oh, but I have to take care that if this one is any larger, then I just have to forget it, because I cannot jump past the nums array, end of the nums array. Okay. Then I will return the Rust index. Okay, in the case, if there is only one cell, reachable with initiated with only one element true. So firstly, when start is 0, max distance is something, but it turns out that I can't jump anything. So in line 25, this should be always true. So I don't do any update. And then in the end, I will return reachables, the last element, which is true. Okay, so I will do the complexity analysis. The time complexity should be n squared because for each cell, each start index, I can jump up to n places. This should be, O of n squared. And for space complexity, what I need is, reachables list. So it should be O of n. Okay, I will execute my code. Oh, this should be n minus 1. Okay. Good, I submit my code. Oh, wrong answer. I forgot something, even though I said it. So if current cell, start cell is not reachable, I have to just continue. Wait, what's the problem is if reachable, oh, sorry. This is false, then I should continue. Okay, time limit exceeded. So let me fix I think of the better approach. Okay, so the optimization I can make from here is that. So when I, obviously this one, line 29, because let's take a look at this example again. So if I find that, let me write one more example. Like this. If I find that I can start, okay. Okay. When I'm here, I can find that I can jump until this cell. So obviously all of this should be true. I don't have to update all of the cells in between. Yeah, I just have to take care that until this node, no, until this cell, all the slots are reachable. And with that being said, and here I can take a look at this, and maybe if I can jump more, I will update the furthest index with that. Otherwise, I still I can just forget it because currently the furthest distance I can reach is here. So yeah, I just have to remember that. Okay, so that being said, let me update my solution. So in that approach, the time complexity should be O of n and space is only O of 1 because all I have to keep track is the farthest distance, furthest index I can reach. Yeah, so let me So this is how I update the max index, and then after that I will increment the current index. Then what I should see is if max index is equal to this. Oh, I think what I can do here, also I have to do here is that I have to make sure that current index doesn't go out of the list. This is what I should do. Okay. Or maybe I can do it in this way. So if this exceeds or equal to the last index, I will immediately return true. So in that way, current index plus max jump is always n minus 2 or smaller. So, yep. That being said, I don't have to take care. Current index will go out of the boundary. Okay, and here, so reaching here means that I couldn't reach the end. Okay, I submit my code. Good. Okay, now it's accepted. So I will quickly wrap up my today's coding practice. So I solved the question jump game. And in this question, I'm giving an array of integers. And my task is if I can reach the last index from the first index, assuming that each position represents the max distance of the jump I can make from that cell. And in my first approach, I created the reachables list, and which signifies each cell can be reachable or not. And then I started from the first cell to the last cell, and if it reachable, then I updated the reachable array cells which are reachable from the current, start index. But this is not, efficient approach. So I came up with the second approach, which is I just have to keep track of the max index I can reach. Yeah, because well, if I keep track of the max index, first the distance I can reach, it means that I can visit every cell before that. So max index is just enough. So with this, until I can reach the cell, current index cell, I try to jump and update the max distance I can visit. And if max distance I can visit is n-1 or larger, which means the last index or further than that, I can return true. Yep. And if I don't return true, and if I find that current index is, more than larger than the max index, which means that I couldn't reach the end, but finished, jumping. And I can't go further than that. So yeah, in that case, I will return false. Okay, so that being said, I've finished my today's coding practice. Thank you so much. Bye.